Hey everyone! I am so excited to welcome you to our first ever Elastic Community Conference. For those of you who know us, community is at the core of everything we do. When Elastic first started as an idea, we were built on the community, and that continues to hold true 10 years later. Community is more than code. It's the foundation that Elastic is built on, helping to shape our products for ease of use and adoption while remaining true to our source code. At Elastic, we spend as much time thinking about the community around our products as we do in building them. Through our free and open distribution, we put the power at the hands of developers and practitioners around the world in a decentralized way. We establish high bandwidth communication channels with our community, which helps create shared purpose that transcends just products and is based on trust. This allows us to form a closed feedback loop so we can build the right products at the right time for today and tomorrow. The wisdom is truly of the crowd. There is so much power in being open. It means our developers are talking directly to users and other developers in a decentralized fashion. Every single moment, there is a loop being closed on a GitHub issue, resulting in a better product. Sometimes slightly, and other times significantly. This type of engagement is magical. We form bonds to organizations that extend beyond just mere usage of our products. One that allows us to quickly react to their needs for both today and tomorrow. The power of open drives a faster feedback loop reflected in our products. It allows for us to collaborate with all of you. It brings transparency, faster development, and ultimately, new innovation. This innovation starts with a single technology stack, the Elastic Stack. It includes Elasticsearch, the place to store and search any type of data at scale, and Kibana, the place to visualize and create user experiences around it. Search is a universal experience, which developers have taken and put to work in so many wonderful ways. This is the power of a technology stack that focuses on speed, scale, and relevance. It takes these core concepts and puts them in the hands of developers who are only limited by their imagination of what can be done with it. And we have taken this search experience and brought it to three main solutions. Enterprise Search, taking a search box and putting it on a website, application, or workplace. Observability, taking a search box and putting it on your infrastructure and cloud to observe it, making sure it is up and running. And security, taking a search box and putting it on your company to protect it, enabling threat hunters as well as protecting at the endpoint and on the cloud. The power of a single stack is economies of scale. By making it faster, more scalable, or more relevant, it benefits all users. By learning to use one tool, developers can focus on better solving their problems. They can take as much data as possible, put it into the right hands, and drive insights and actions out of it. And the power of solutions is made more powerful with the choices we give you to run anywhere. You want to run us on premises, we're here for you. You want to use containers to run in a hybrid environment with Kubernetes, we're here for you. If you want us to manage it for you in our cloud, we provide immediate access on our website, where you can select your favorite cloud provider and region from AWS, GCP, or Azure. And it all starts with data. Data has gravity to it. If you are running on Azure, you would want to deploy your observability solution next to it. If you are running on GCP, you would want to run your security solution next to it. If you are running across clouds and on-premises, you want to be able to search across it. In all these cases, we have your back. We want you to have the flexibility to move fast. We want you to have the flexibility to start small and grow with us at whatever pace is best for you. We want you to have the flexibility to use as much data as you want, in any way you want, without pricing standing in your way. This is why we've always had a single pricing model. For all of our products and solutions, the pricing is the same. While our vendors charge by query, document, ingest, agent, endpoint, user, and other variables, oftentimes combining several of these at the same time, we only charge by the resource or data you use. Simple. You want to move as quickly as possible, and we won't stand in your way. You won't be penalized when you want to expand from one use case to another. Community is at the core of Elastic. You are at the core of Elastic, and I really appreciate you all allowing me to take time out of your day to tell you that. Also, please join me later in the conference for a panel discussion with Heather Meeker to discuss our license change, moderated by our very own Philip Kren. I'd like to introduce a few demos, portions of our products that the community might not have as much exposure to: App Search, Observability, and Security.
Hey everybody, I'm Casey and I am a product manager here at Elastic focusing on App Search. Today I wanted to take you all through a really quick demo of the App Search web crawler beta. So let's get started. So I've spun up a deployment on Elastic Cloud. I'm on version 7.11.1. The web crawler beta released as part of this big 7.11 release just a couple weeks ago. So if you want to give this a try yourself, go spin up a new deployment on Elastic Cloud. So the first thing I'm going to do is create a new engine. And what we're going to do today is crawl the Elastic blog. I think that's probably a pretty good use case for a web crawler-based search engine. So we're going to call this Elastic blog and create our engine. It should just take a second or so. Oh, perfect. Engine's already taken. Here we go. So the first thing we would have to do when creating any engine is add data to it. And the great thing about the web crawler is it allows us to do that really quickly. So here on the engine setup view, we're going to go and navigate to use the web crawler, and we'll add our domain name. In our case, it's elastic.co. And since what we're aiming to do here is just crawl data from the blog, I'm going to make a couple of changes to all the rules and entry points you see here to make that possible. So entry points are exactly what they sound like. It's the place that the crawler chooses to start, and you can customize that by passing in any URLs. So in our case, we care the most about the blog. So I'm going to use the blog as our entry point. And since we also only want to crawl pages from the blog, that's where crawl rules come into play. With a crawl rule, we can decide exactly what the blog or what the web crawler does when it sees a URL it comes across, whether that's like ignoring it or following it and indexing it, and all that. So what we're going to do, we have a default rule down here. It says allow with a regular expression of literally everything. That's a pretty good place to start if you're just going to go and crawl a whole website. But since we're going to crawl something a little bit more specific, we're going to add a rule on top of this to actually deny everything. It's also important to realize that rules are evaluated hierarchically here, like all the way down the list, starting at the top and then working its way down. And then since we want to crawl content from the blog, we're going to add another rule for allowing content that begins with, and begins with is going to refer to the URL itself. And we want to allow things that begin with blog. And I think that's going to put us in a pretty good spot here to go and get some good blog content, which was the goal of our whole exercise. So what we'll do now is start a crawl. We should see that get going. And yeah. It's crawling now. So how do we validate that, we're actually seeing the things we want to see, or that the crawler is actually doing the things we expect? Well, there's a couple of ways. One thing we could do is just go sit over here on our documents view and wait for documents to come in. And you can see we've already seen a couple of documents, but we can also, hop over to Kibana and take a look at our logs, and we'll start seeing the same sort of events popping up inside of our logs. So you can see the crawler is visiting all sorts of URLs, but is specifically looking for ones that begin with blog. And that's it. So now over here in our app search engine, we have a page of indexed documents. We'll soon have many, many more in just a really short period of time. And we're well on our way to creating a great site search experience with App Search. And that's it. Thanks, everybody.
Hi, my name is Alex, and I'm a product manager on Observability team. The community has been such an essential part of our journey. Many of you know it, and it's likely started with logging in the early days of the Elk stack. Today, I want to highlight the progress in other observability pillars and how we are connecting EPM traces, metrics, and logs together. During recent releases, we focused on improving user experience to enable better troubleshooting. In this short demo, I will perform a root cause analysis of an issue in my demo application. Let's start with EPM, which, by the way, stands for Application Performance Monitoring. First, I see here all services which are instrumented with EPM agents and their key metrics like latency, throughput, and error rates. Some of the services are healthy, but others are in critical state. The state is calculated based on anomaly detection, which is powered by machine learning. Since multiple services are having problems, where do I start? Service Maps View would help, as it shows how all services are connected to each other and which other backend services depend on, like databases or other cloud services. I suggest that product catalog service is the most common denominator across all services in critical state. My hypothesis is that it could be the source of all problems. When I drill down into the service details, I can see a lot of information. Notice that this particular service is written in Go language. It is running in Kubernetes in a Google Cloud. Latency graph is suggesting that the problem happened yesterday evening, so let's drill down into this. Response time jumped from milliseconds to 5-6 seconds or higher, and throughput got impacted too. This means that the problem was quite severe. I also confirmed that both transactions or endpoints which this service exposes experienced similar problem. There were no errors happening at the time, which is great, and all container instances look equally healthy based on metrics like CPU and memory usage. But PostgreSQL database, which product catalog service depends on, was having a problem exactly at the same time. This makes sense, as databases are often causing problems to the upstream stateless services. Now I'd like to drill down more into the get product transaction, which was impacted the most. Looking at the distributed trace at the bottom in this waterfall view, I can see that normally performance of the database is quite fast. But when picking up slow traces, time to connect to PostgreSQL is taking 15 seconds or more. As a last step, I'd like to confirm whether this issue with connection to PostgreSQL truly affected all the services we saw in the beginning. I'm switching here to the full trace view, which reflects what happened end-to-end when a user clicked on a page, including time spent in the browser and all of the downstream calls. This is a complex transaction, and it is very clear that not only PostgreSQL database was the root cause, but it also was called multiple times to retrieve product details for several individual products, which only made it worse. To conclude this demo, I'd like to remind everyone how hard it is to find the root cause of a problem in a complex microservices environment. Usually you have multiple hypotheses and need to verify them. That is why we correlated logs written by each of the services with the end-to-end traces. Logs view here displays exact log lines written while processing this request by each service. Such information is extremely valuable to better understand the root cause and to reproduce the problem. In our particular example, logs show the product IDs requested, which would help to verify whether all products are having slow response time or only a selected few. And definitely, I would be able to reproduce the problem much easier having this information. Thank you. We hope you enjoyed this quick overview, and I would like to encourage everyone to give some of these new features a try.
Hi, everyone. My name is James Spiteri. Some of you might recognize me or recognize the name from the community Slack workspace. I'm pretty much on every security channel there. I'm here to give you a really quick demo on ElasticSecurity. So let's just go ahead and dive right in. So I'm right now inside of Kibana. I'm in the security solution. And I just want to call out that everything here that you're going to see is included as part of the product. So you can pretty much download and use this right now as you see it here. I'm going to start off in our detections page. So Elastic Security is mainly made up of two components, where we have the SIM, or what was more traditionally known as SIM, where we're going to do security analytics and investigations and that kind of thing, as well as endpoint security. So we do ship an endpoint as part of the product, so you can actually use that as well. It has malware preventions and detections too. As part of that, as part of Elastic Security, you get over 400 detections as well, created out of the box. And they are actually created on an open GitHub repository. So you can actually go in here. It is the same repository that our own research team develops in. So they are developed in the open, and you can actually actively contribute. So we've had quite a few community contributions to these rules, which is fantastic to see. And we even published tooling and tests that you can use if you did want to implement something like detections as code. And we've even had contributions to those tools, which is great. So thank you for doing that if you're one of those individuals, and please keep the contributions coming. Just taking a closer look at the product, right? So in the detections page, this is pretty much where most analysts would start off if they had to use Elastic Security. And there are some other pages which sort of display like a generic host and network view, but let's talk a bit about detections. So as detections start to trigger, these were all triggered as a result of a real malware sample being detonated based off of APT28, if you're familiar. I have a couple of choices about how I can dig in to these alerts. I can also do a few operations around them. So I can add them to a case. So you do get case management included as a nice way of keeping things neat and tidy during an investigation. You can add things like exceptions. So you can have a full rule exception workflow that you can use. So this is all what you get. If I just click on one of these, I do want to show you sort of the level of detail that you get. So not only do we ship the rules, but you get the full query that we ran. This is an example of our EQL, so event query language, that's running here. So we don't hide any of that. You can see everything within the product, not just in the repository. We support things like MITRE ATT&CK, tactics, and even down to the sub-technique level. So this is all of what you'd get, right? All bundled in there. Now, if I wanted to look into the sort of raw data, there's a couple of ways to do that. One of the more intuitive ways is using the timeline. So I'm just going to go ahead and click this investigate in timeline option. And what this does is the timeline is a really intuitive way of building investigations, because you can even do things like dragging and dropping. So if I wanted to, I can grab this host name here and actually drag it into the timeline. So even if you're not too familiar with our query languages, you can actually interactively use this as well. And you can have multiple elements. You can build a pretty sophisticated query. Within the timeline, there's a couple of other nice features like the ability to leave notes. So you can leave a note here in Markdown syntax, and it will show up here as sort of a detailed note. And we also have a graphical analysis view. So if you wanted a more sort of a process tree view of what happened, we do support that. And at this time, we support it for our endpoint data as well as sysmon. So if you're using WinLogBeat with sysmon events, you can actually get this view as well. What I'll do is I'll open up a timeline I've previously created just so you get a good view of what that looks like. Let's just do that really quickly. And I'll use some sysmon data for this as well. And I'll just load up one of these events. And you'll be able to see sort of the extent of being able to look at that graphically, because sometimes when it's a more extended tree view, it's even more significant. So something like this, which is really powerful. Within timeline, so not within just the detections view, you can use cases as well. So you can attach to a new case in its graphical form or even to an existing case. If we just hop over to a pre-populated case here, so you can see what I mean. It's really a really rich experience because we support things like Markdown syntax, so you can leave images, links, but pretty much whatever you want. So this is all included as part of the product. Obviously, there's way more we can go through, but we don't have too much time for a short demo. So if you did enjoy what you've seen, please go ahead and try the product. You can use it. Everything I showed you can use as of today. Just go ahead and download the news, and do reach out to us on the Slack workspace in the security channels if you have any questions. So thank you very much. Please enjoy the rest of the conference.